think it would be good if we just like went around and maybe introduced who we are, so that everyone knows each other. Does Gary want to start? Name is displaying. Okay, if not Gary, maybe Juan.
Hi, so I'm Juan Rodriguez, and I'm the developer of the SSCheck library for Spark.
Thanks for joining us.
You?
Krishna, do you want to introduce yourself?
Hi, I'm Krishna. I'm a student. That's it.
Okay, that's good. Lars?
Hi everyone, my name is Lars Abelsson, based in Stockholm, Sweden. I'm an independent consultant helping companies with data processing solutions, currently at Spotify. I've held a couple of presentations online on testing and testing data pipelines. But my previous career was as a test engineer at Google, so this is the combination of my two careers. Thanks for inviting me.
Oh, thanks for joining us. Leslie, do you want to introduce yourself since you just showed up?
Yeah, am my sound working?
Yep.
Okay, so I'm Wesley Kerr. I'm at Riot Games right now, and we make League of Legends. So I'm interested to hear more about how we can get better at testing PySpark offline and doing more with it.
Awesome. Oh, sorry. Last but not least, Jonathan, do you want to introduce yourself? Oh, and Gary's back. Yeah.
Yeah. So hello, Johan. I'm a software engineer working with Spark since early January this year, and as we'll be moving into production very shortly, well, having more knowledge about testing and sharing what I can expect. Seems
Cool.
what could be helpful today.
Awesome. And Gary, you want to introduce yourself? Is your connection working out okay? Or not, we can just move on. Yeah, awesome. So there's a bunch of random topics that I suggested, and other people are more than welcome to suggest their own topics, but I think it would be good for us to maybe go over what the state of the different Spark testing libraries are, and where we see them going as maybe a good starting point. Does anyone want to pick that off? I can talk about the library I work on, but I know we've got the SSCheck guy here as well, if you want to say something.
Okay. Okay. Yeah. So SSCheck was a university research project where we wanted to see if combining property-based testing with temporal logic would make sense for testing Spark streaming, because Spark streaming has this temporal component. So we did this prototype, and we have evolved it a bit with these quantifiers that we added. We did a presentation in Apache Big Data, but at this point, we don't have much resources, so the problem is a bit abandoned. So in my opinion, what would make sense is contributing to some other project, because otherwise we don't have any resource to continue in developing. And well, I'm not really sure how many people have really used SSCheck in practice. So I'm curious about that. I have the impression that not many people. I don't know if it is the documentation. We have the documentation is quite bad, I have to say. I don't know if the whole concept of temporal logic is too complex. I don't know. So I'm very interested to see what people have to say. If someone has had any experience using SSCheck here. So that's it.
My experience with SSCheck is mostly limited to trying to steal the good ideas from your work. But has anyone used it personally?
I have not used it. The closest that I've seen is that a fellow at Spotify is using Scala check on scolding pipelines. So that's the only example of like property-based testing that I've seen. But that team is apparently quite happy with it. So the concept is the same, but the underlying technology different.
Yeah, that's cool. Yeah, so there's also Spark testing base is a library that at least some people use. It's primarily based off of how the unit tests inside of Spark are structured. At least that's where it got started initially. And there are other people who contribute to it beside myself. But I have yet to trick anyone into sort of doing a lot with it. But there's been some good. Its own documentation is maybe not that great, but people like Jesse Anderson have written blog posts about it, which I think have done a much better job of explaining how to use the testing libraries than any of the documentation that I ever got around to writing. Are there any like Python focused people here, and what are you doing? Are there any people from like the Python testing libraries around, or people using the Python testing libraries?
I think as most as we've done is used just find Spark to get it set up and then basically collect everything back and try to do some testing that way. Our biggest hang up right now is Hive because mocking out all our tables is nasty. And we do a mix of PySpark and SQL quite frequently.
That makes a lot of sense. Collecting the data back locally is definitely, I mean, it limits what we can do, but it makes it a lot easier to fit into the existing sort of testing frameworks that we're used to working with. And I know there's some tools to help in Python testing, but it sounds like no one, at least no one on this call is using them. But so your main pain point is with like support for making essentially mock Hive tables to test your Python code against?
That's been one of the big blockers for us of actually being able to test stuff out, but it could also just be attributed to laziness as well.
We think laziness is a virtue in software, so that's fine. We should find a way to make that easier for you. Are there other users who are running into different pain points? With their Spark testing?
I haven't used Spark testing base, but I've tested 2 different Spark applications in my career. And in the first case, there was a batch application. And what we decided to do was, instead of using an existing framework, to create the input data for each test by just writing Parquet or Avro down to disk, and then spin up a local Spark instance, read it up, and then write it out to disk again, and then having to test Oracle read it from disk. That worked fine, except that the Spark context is fairly slow to create. So that was I think the single pain point that we had. I see I'm poking around in your code here now, Holden, and I see that you're simply reusing the Spark context. That's essentially what we did. I remember having some issues that it could affect test cases, but I don't recall how and when. This was now some time ago. Have you or anyone else run into issues with reusing Spark context like this? Is there any risk in doing so?
Yeah, there is. This often happens. So the biggest issue that I've seen with doing this is essentially your job gets into a bad state, or your Spark context gets into a bad state, and you have one test failure that like cascades all the way down. And yeah, forking between test suites that's a really good workaround. One of the things which isn't yet supported in Spark testing, and we probably should, is actually running parallel Spark contexts at the same time, so that you can run your suites in parallel. Right now, it's just we choke on some things because of some Spark internals that way.
So the Spark context has to be a singleton, effectively?
Effectively, right now, it doesn't do so well when there's two of them. There are ways to make it work, and that's done inside of some of the Spark tests themselves, but it's work that I haven't bothered to make happen inside of the testing library that I work on. I also know that there's like two other very different approaches, and I'd be really curious to hear if anyone's used them. There's certainly some limitations with it, but it gets around the Spark context being slow. There's like this dummy RDD implementation in Python, and then there's another one in Scala, which essentially gives you a mock RDD instance. I'm gonna look up its name really quickly. Conetics or something. Context. Let me actually load their. Let me paste their website in the group chat.
So one of the reasons we decided to sort of write data sets to disk before the test case and during the test case was based on experience with testing Apache Crunch applications, where you have a mem pipeline implementation that's sort of in memory. Turned out when we used that for testing, it masked a bunch of serialization and I/O bugs that were not triggered in the test cases, but hit us in production. So we decided to sort of make the test more authentic and to avoid the sort of in-memory data structures in order to catch more types of bugs. So I've become a bit wary of like mocking in-memory data structures and try to have my test more realistic over time.
Yeah, that seems very accurate. It definitely limits the kind of bugs you can catch, and you're going to miss out on a lot of very painful ones. But for people who have maybe for test-driven development folks who like write a lot of tests, maybe mocking makes sense some of the time. Certainly, you would still want some more complete tests, but you could do some of your lightweight testing with mock RDDs possibly. And I think this specific project, from chatting with them, they offer the ability to run with mock RDDs like locally, and then in your CI environment, you can actually have the same tests run, but they'll run against a real Spark context, which I think is a really cool idea, right? Because like when I'm just doing my like rapid dev, I want it to go really fast, but yeah. Oh yeah, cool. And the people who are chatting, you can totally speak up as well, because then it's not just me on the video, and it looks like we have involved people. But if you prefer to stick to chat, that's okay too.
Okay, well, I can jump in. Hi guys, I'm Sam. Thank you, Holden, for organizing this. It's really, really useful. I specifically wanted to point out that, well, in regards to the PySpark stuff, we've used your test base, and then we've also used PySpark because we wanted to do behavior-driven development, BDD tests. But I'm curious to see what everyone's doing in the call, because not everyone uses Spark as just Spark. Like they have something like Apache Uzi, something like Airflow in most cases, something to submit jobs. So I'm curious to see what people do with testing that pipeline. Are people just testing their pure unit testing, the Spark application itself, or are you testing the entire pipeline? And speaking to the Airflow guys in Gittin, there isn't a clear-cut solution to this yet. But ideally, I want to write my DAGs or write my piece of code that submits Spark applications to an existing cluster or creates a new cluster. But I want to test that out with a data set that I expect to be shaped in a certain way at the end of the transform. And there isn't basically an end-to-end integration test, and there isn't like a clear-cut industry standard. I understand that, but it's conversations like this that really help us get there. So that's me.
That's really awesome. I was hoping someone else would respond so that it'd be more like communication. But yeah, I think there's some really interesting stuff, and it's definitely we're really far away from that. Oh, does someone else? No. Okay. I think the things that I've seen get closer to that are some of the Docker-based sort of test stuff. And does anyone look at the Databricks Spark integration test package? It's not designed for testing our own tests, but I think it's a good start of some ideas that we can maybe borrow and refactor to make more general if we think that they're going in a good direction. And Josh is a good person, although this is pretty old, so admittedly it's from 2015. But if it looks like what people are looking for, we can probably convince Josh to help us with a little bit of it.
So I have a couple of answers for the testing the full pipeline. I've basically seen two variants here. One is to ignore the workflow manager, as in Airflow or Uzi or Luigi, and have a sort of pipeline test that stitches multiple jobs together. So if your Spark job, for example, is represented as a class with some kind of main method, then you would have an umbrella class calling one job after another in line that mimics the production pipeline that you have. That has the drawback of you have to maintain a parallel pipeline should be then identical to the pipeline that you have defined in Airflow or Luigi. It has the advantage that you can then run the full test pipeline inside your IDE directly from IntelliJ and bring up the debugger and so forth. So that's sort of option A. I've used that with success at some project. Option B is to instead use the workflow manager and hack around hack around in your job definitions and introduce a layer of indirection where you say, okay, the output is not going to be on the production HDFS, it's going to be on local files instead. There are no ready-made tool for that, at least not in Luigi. I don't know about Airflow. I would not recommend doing this with Uzi. I would guess that the DSL is too weak. But we've done it at Spotify with Luigi, and it's a bit of work, but it sort of works. But that also adds some extra maintenance since the workflow managers are not really built to do this. I'm not. I would say I prefer the integrated Spark job all in Scala approach, version 1, but both has pros and cons. One alternative to hacking around in your workflow manager to run the test on local disk is to have a staging environment where you run your sort of parallel production pipelines first for like 1 day or 1 round before they're pushed into production. And that would also be implemented by hacking around the output paths in your workflow manager. Does this make sense?
Yeah, it's actually touching upon a lot of the pain points that we're feeling. So we've gone down both routes really. Initially, we really unit tested the application completely, but we felt like it was still risky that our production DAGs, like the logic of job A, job B, and job C depend on job D, or vice versa. D depends A, B, and C. That logic is really in the workflow manager, and we had 2 options. One being actually run the workflow manager in a CI server, because ideally that's what I want. But tools like Airflow and Luigi are not. We're struggling to get it to run multiple pipelines. We're now based on having a dev and production folders in our Git repo, or have 2 Airflow servers. That's our 2 options. Because the strategy of having an integration test that is just a duplicate of your DAGs, in my experience, you will always find your DAGs at some point, whether in the short term or definitely within the long term, they will not be duplicates. You'll be like, the testing is fine, but there was a hotfix that needed to go out, and the production DAG is not the same as your test DAG, which defeats the purpose. Ideally, you want to put your DAGs in a box, and you want to say, just run this test against this thing, so I can be sure after my Jenkins build or my CI build is green, I know these are the DAGs that will go into production. These are the same DAGs that go into UAT or QA. It's the same. It's the same component. And again, that's from my background on web development. It might not be applicable to data engineering, but to me, if I'm developing an application or a pipeline in this scenario, I want to make sure it's robust in every single environment. And that's kind of what Docker does. It's repeatable infrastructure. So it's always the same package, and it's what continuous delivery was really aiming at. So at the moment, what we're doing is we're running 2 Airflow servers, but it's still 2 duplicates, but at least the DAGs, the code bases, are the same. The alternative is to move the logic of the DAGs into our application. Then you can just run it off a CI as long as it has Spark in the shell. But the problem then is things like retries, things like alerting, all the stuff that workflow managers give you, your application will have to do. So yeah, I don't have a clear-cut answer, but I just didn't. I wanted to see if people in the call have faced the same problem. And apart from duplicating an Airflow server or a workflow server, I'd rather not do that. But I'm glad at least that we're not missing something obvious. So that's me.
No, you're not. We have the same pain points. I think the strategy of having a sort of a pipeline tests, the option one I mentioned, pipeline test all in Scala integrated. I think that relies on the assumption that your DAG is simple and does not need testing. So you just stitch, you don't do the whole DAG even, you just stitch a straight pipeline of jobs together. And if your DAG is simple, and if just wiring together the dependencies, if you make mistakes in your DAG, your production will have a hiccup. But since you're dealing with batch processes and usually run things daily, if you have a hiccup, you notice and then you fix it and then you move on. So it can be an acceptable risk. Now, as DAGs get more complicated, unfortunately, they tend not to be simple. So at Spotify, we have these rules that we're going to use the latest data set from somewhere. And but if it's not present at the time we're running, we're looking back 3 days, but no more than 3 days, and so forth. So the DAG ends up being complicated and actually contains business logic. So, and the assumption doesn't really work.
So it sounds like it's two completely separate concerns. One is I'm running data through this pipeline and I want to see that the data is correct. And the other concern is I want to confirm that my DAG is correct. So one is Spark testing, one is Airflow or some other tool. That's what it looks like to me. It'd be interesting to see how to stitch them together.
Yeah, I think stitching together both the unit testing stuff and also like more of the traditional integration testing is challenging. Certainly, it seems like all the libraries we have right now are very focused on the integration testing side, and so maybe you should be considering some libraries focused more on the integration side. But I don't know. So when I've considered working on stuff like that, it's always felt like the integration and testing side often depends, like the kind of support you need to make integration testing is too specific to each pipeline to really make a lot of sense to try and make libraries around this. But what are other people's thoughts on that?
This is exactly what, following a conversation we had at work today, which is why people haven't built something like this, because, well, I'm a lazy developer, so I was hoping there's something out there for it. It's because it's very hard to do something that's cloud agnostic, really, because things like initial step of any of these workflow managers is to create the cluster or submit to an existing cluster. And Spark Submit has made it somewhat agnostic, but most people who are on EMR, if they're doing something simple, would add a step. Or create a cluster on EMR is completely different than creating a cluster on Mesos or on Databricks or on GCP. They're all very, very different. So I think that's the reason why there hasn't been a clear-cut way of doing integration. People are always like, okay, these are sort of small jobs, and as Lars said, if it fails, it's not as vital as when a website goes down or as when your banking application goes down. It's because most of the past ETLs have always been like batch processes. Oh, okay, we don't have data for today. It's a pain, but it's not as major as Amazon's gone down and you're losing millions by the second. So that's kind of my opinion. But it's certainly something that that I'm very eager or very keen to get involved in if people want to write an integration testing framework that, you know, focuses on a cloud platform for Spark.
I think the workflow managers are very production oriented, and that's what was primarily in mind when they were built. Testing wasn't a part of the requirements, and therefore it's difficult to stitch on. With respect to agnostic, I would say that Luigi is fairly agnostic with respect to different environments. It has been used in so many environments now that they're just, you know, each new environment is just yet another class. And we typically run very heterogeneous pipelines. So the project I'm in now, we have a combination of crunch jobs and then scalding jobs on on-premise Hadoop clusters, and then switching to Google Cloud jobs or Apache Beam data flow jobs running in Google, and then we emit stuff to Postgres databases, all in the same pipeline, and that works fairly or surprisingly well, at least. I did a hack at some point to write a workflow manager prototype that had testing as a requirement, and I implemented that by having a sort of a layer of indirection where you could say, oh, by the way, everything that says HDFS something, actually translate this to local files or whatever. And maybe that solution would lead to an end, but I lost the use case before I got finished with it, so that's abandoned code somewhere. Let me know if you want to pick something similar up, and we can bounce ideas, but I'm not picking that one up right now.
As a recovering Perl developer, I believe is the good expression. When someone says something like that, I think, oh my God, I can use regular expressions and turn my one problem into two problems. But honestly, it seems like for the files, we could get pretty close with some pretty bad regular expressions, right? Like, we could just write some rules to dynamically rewrite our pipelines. And I saw this really cool talk from this thing called Atomus, which takes the same approach, except instead of regular expressions, like actually tries to use a grammar and be classy. So we could look at making maybe some tools with that would make it easier for people to dynamically rewrite from their sort of prod to their test pipelines for things. Probably Luigi would be the easiest one to start with, I would think, or most reasonable. And it sounds like there's maybe enough people interested in trying to do people, like, when they hear that, think like, oh my God, that's crazy, I'll never use that library? Or do they go, yes. Yay. Okay. So I got a thumbs up and one like, yes, we will soon take over the world. So I think maybe the three of us should at some point have a conversation about how to do evil things, either with regular expressions or ASTs, in the service of the Greek pipeline up in the sky. So switching tracks a bit, or jumping back if people are okay with it. One of the things that we mentioned earlier on was like, we're not sure why people aren't using certain libraries, but we have some feeling that it might be related to documentation. What are people's experiences trying to read the documentation for the testing libraries, and how can we make them more approachable to users? What do people think? Yeah, okay, I mean, that is often my approach. Okay, yeah. So Russell, who appears to not want to speak out loud for some reason,
Sorry. Sorry, didn't mean to be all hidden. Yeah, I got a lot of other things coming in on other screens. Yeah, I really think that unless you do examples, you kind of lock out the majority of developers. I'm sure everyone here has had an experience where you have a blog post, you write one line of code, and then you see people asking about it, or you see it on Stack Overflow like 1,000 times after that. And there might have been documentation before it and after it explaining exactly what you had to do to modify that code to do whatever the question is. But that never got read. All that got read was that code, which got pasted in and run. So I think you just need to have examples of how do you set up this, how do you run a test or whatever, something like that.
That definitely makes a lot of sense, and it definitely it matches some of my experiences. Certainly with I wrote a blog post, and now it's on Stack Overflow, and it's lost all of the context around it. God damn it. But on that note, are there any well-tested open source Spark projects that people know of? I mean, there was the Spark Cassandra connector was mentioned a little bit earlier. Are there other examples of well-tested Spark code that people can look at?
There's a Spark project that's very well tested, but I can't think of any off the top of my head. However, I'll just mention what my experience when I was trying to learn how to write PySpark tests, and there is very little documentation on writing PySpark tests compared to Scala tests. I think you can easily find a way of writing Scala tests from Spark Scala tests from blog posts here and there. There's just a wealth of information. There's a wealth of code when it comes to writing your own Spark Scala test. But for PySpark tests, it was a little bit more difficult, in my experience, finding codes, descriptions, and identifying how to just write a simple word count test. It wasn't as easy. So certainly adding more code examples of here's a simple word count test. Here's a simple test to validate you're doing X amount of transformations, or just a CSV to Parquet Spark application. I certainly think we need a lot more of those.
Yeah, that makes a lot of sense. I think, unfortunately, most of the really well-tested Spark applications end up being companies' ETL jobs, and the open source Spark code that we see tends to be things like the Spark Cassandra connector, which is very good code, but the things you need to do to test a Spark library like that is very different than the kind of testing someone making a traditional ETL job would necessarily write. So they probably find it difficult to find good examples. And certainly I'm responsible for some of that. Because as someone who writes Spark books, I don't always have a lot of test examples, and it's one of the few places where you really should have them, and I just my editor says I'm over page count already, so.
Is this an opportunity for another Hello World, but in Spark as an ETL with tests?
Yeah, I think a good Hello World ETL in Spark, but with actual proper testing would, it sounds like everyone thinks that would be really useful, especially if we did it across the supported languages. I have no idea how to test our code relatedly. If anyone knows how to test our code.
Test what code?
Spark R code. Yeah, I'm mostly getting blank faces on the Spark R code. This is legitimate. Russell has a thing. What do you have, Russell?
Yeah, so we built a small example application, which I'm looking for, and this is definitely not going to cover everyone's use cases, and the tests I wrote for it are terrible. But I basically wrote a embedded Cassandra Spark ETL thing where all it does is makes a table and moves data from one table to another table, and I added on the test classes just to show that you could write tests for it. I didn't actually write any meaningful tests. The tests are just like, look, the testing framework works, so you could actually write more tests here. But then I have the same problem with the language thing, is that I am not super. So this is unfortunately part of working at a bigger enterprise-facing company, is I don't want to encourage people to use certain languages. That increases my support burden. So
Yeah, I understand you.
I wanna make sure all the things that our support team is most able to handle are like up there as the primary examples. Because like I said before, copy paste is a lot of the code that we see running through here. So it helps if it's all there. I mean, I have no idea how you would test R. I don't know. All my Java users have enough trouble just like passing class instances around, that getting to the testing stage is like a way beyond that. So I'll find this repository eventually.
Cool. Yeah, you can maybe just follow up on the mailing list thread. Okay. That sounds good.
Well, if it helps, let me try and share how we're doing testing for our ETL code. We've got a variety of different data sources that, mostly CSVs and JSONs. That's most of our data. A lot of the pain points that we need to test for is the fact that the pain points everyone feels in their when they're writing ETL code that perhaps is not really shared as much on blog posts, is the fact that so much variety of data out there. It'll come in all sorts of different formats and different shapes, and you as a data engineer need to adhere to that in your code. You have to make sure your pipeline stops bad data coming through, wrong data coming through in the wrong format, in the wrong shape. If it's not there at the time, you've got things that your end store, your end data warehouse, your end database needs to be in the right shape, and the unstructured data coming in, you have to process it. So what we're doing is we first initially take all the raw data that is very hard to deal with and extract it and save it to Parquet, because then it's very easy to transform, and we have tests to do that. A test to ensure that we load a sample test CSV in the right shape, and we are outputting it in Parquet in the same number of rows. And then we're testing how we deal when stuff is malformed or stuff is just empty, because your third parties might just give you empty data. So the next step is what we do to the data modeling tests, where we now have a data set that we can deal with in the shape we like. It's still in the same raw shape that we saw it, but it's just in a format that's easy to move around. And then we transform it, and we check that the output transform. An example of, we have one table that depends on 3 things, and those 3 things are right correctly. We can now create that end table. We ensure that things like the term is called invariance, but I don't know how you would define it in data engineering. But things like they have to apply. You can't have this rule break A, B, and C. For example, if you think about it in an accounting term, you can't withdraw money if you don't have cash in your account. These sort of rules that your data set need to adhere to, that your data analysts, data engineers, you don't want them to come up and say, this data doesn't make sense. How can a user have viewed a site or viewed a transaction when they never signed up? So things like that you have to make sure you test for. So you don't find a lot of articles or blog posts about these problems, everyday problems that you definitely feel. So I'm more than willing to write one and give samples of what our tests are. I'm not the greatest writer, so don't get too excited, Alden. But I am willing to share that, and people can just add to that, to their experiences. And it can start as a really crappy blog post I write, but then people can share, and then it could be a gist somewhere, you know, that people can learn from. So that's an idea.
Yeah, so +1 on the invariants. We use that a lot in my current team. It turns out that we have very wide records, and there are so many invariants between the fields in the records. So we express invariants for each record, and also invariants between the inputs and the outputs of each test. So for example, in many jobs, the number of inputs and number of outputs is equal to the number of inputs, and so forth. And those invariants that are applicable for each record, those can also be used in production data quality monitoring. So you can take the same invariants and check if they actually apply on your production data sets. And in theory, they should. In practice, they probably don't.
Okay, well, I'll write something up. I'll send it to a specific list of people where I can get feedback, where you can tell me it's crap, and then I'll improve on it, and that's when we can share it with other people. And, you know, the more ideas to it, the better.
That sounds great. So it's been like close to an hour, and I haven't had any coffee for almost an hour, and that's about as long as I can go without coffee. So if people are okay with it, I think maybe this is like a good stopping point, and we've got some different things. I'll try and trick some people into using regular expressions for tests, or AST manipulation if we decide to get fancy. And no worries about being distracted. I completely get it. And maybe we'll do another one of these in like a month, and we can see where we are. And hopefully we can make Spark code better tested out there, and maybe not cause the next global financial collapse with our untested big data jobs. Yeah, I like getting paid. So I think this is important. So thank you everyone for coming. I hope this was at least somewhat useful to everyone. And if it wasn't, don't feel obliged to come to the next one. It's all good. And if you missed part of it, I'm going to try and post the recording. So thank you all.